Now we discuss all the types of milling process. Now it's time for other machining processes. We first have planing and shaping. They are highly similar processes, and you can see some typical parts which can be machined with the help of planing and shaping. And you can clearly see that they're all 2.5D shapes. We cannot actually machine completed 3D shapes with planing and shaping. They are quite simpler as you see. They are very similar to the results of extrusion process. So we have a constant cross section, but the length is higher. In planing, what we do, we have the workpiece doing a reciprocating motion, going back and forth all the time, but we have this tool stationary. So in a moment, actually, it machines removes material, but in the shaping process, it's the vice versa. This time, instead of our workpiece moving, our workpiece is stationary, but tool is doing the reciprocating motion. And the other things, other fundamentals are the same. In some cases, our tool may be removing material in only one direction, and that means it's actually has a higher non-cutting time. And obviously, once you have such a non-cutting time, a higher non-cutting time, that will decrease your manufacturing efficiency. And if it's an important issue for you, you need to consider doing another manufacturing operation or using another machining operation. We have different shapers, horizontal shapers or vertical shapers, but as I said, the fundamentals are the same. In shaping, we have the workpiece stationary, but the tool is moving, and in the planing, we have the tool stationary, but the workpiece is doing the reciprocating motion. And we have an example shaper in our machine shop, but not using it a lot since instead we can do the same operations on the milling machine, on CNC milling machine. These days we don't need to use it. Then we have another machining process. It's called as broaching. The types of the machines which are used for this process is called broaching machines, and the tools are simply called as broaches. I will show you some examples in a moment. And the main actually function of broaching is to open some complicated profiles on the internal or on the outer surface of the parts. So they they are not removing too much material, but they are opening some complicated shapes, profiles onto these surfaces. And this is a typical broach uh, typical broach, and as you see, we have many teeth and this type of cutting tool. You can assume that it's somehow similar to saw tools, but a bit different. Obviously, you can see an example workpiece which is just broached a moment ago, and this is the broaching tool or just simply the broach. You see, we have many cutting edges, many, let's say, peaks here, and they're all responsible for removing material. But the thing is that they're not removing too much material. So what we do, we start with like a kind of a bushing. But once you pull your broach through this bushing, or you may also be pushing into the bush instead of pulling it. After this process is over, with a single pass, you can obtain such an internal teeth on your initial workpiece. So it's can open such actual teeth in maybe just a few seconds. So it's highly productive, especially for such kind of mass production. You may use broaching machines or broaching uh, tools. We have some other examples here. You see, they start again with a kind of a bushing, but open different keyways, different shapes into the bushing. And we also have such special machines. This is a vertical broaching machine. So probably I think it's a push type. So what we do, we put the workpiece here, and then this broach is here. So we are pushing the broach into the workpiece, and with the help of the cutting edges, we can open such special profiles onto the internal surface of our workpiece, but it doesn't have to be an internal surface. You may also open such shapes onto outer surface. And the total depth of cut of the brochures is actually equal to the summation of these depth of cuts of each tooth. So the distance actually between the two dashed lines is equal to cut per tooth. So if you sum all these, you can obtain the total depth of cut in this bushing process. And as in the case of other machining processes, we have some angles. Angle related with the rake face is obviously called as rake angle. Then we have clearance angle again. It's related with the flank face and the machine surface. Now let's have a look at with a detailed view of broche. So this is a pull type, which means that we are pulling this broche through the hole or over the surface, but since it's circular, probably we are pulling it through a hole. And then if you look at the main, let's say, machining part, machining teeth, we have some roughening teeth. So the material removal rate is a bit higher here. And then we have semi-finishing teeth in between the finishing teeth and roughening teeth. So with the help of finishing teeth, we remove less material but increase the dimensional accuracy and the surface quality of the hole. So with a single pass, we, we can have various profiles on the internal surface of the holes or various profiles on the outer surface. And in addition to these teeth, we also have some pilots. This is called front pilots, rear pilots. So they're actually kind of aligning your tool in the machine so that, again, your eccentricity or the dimensional accuracy of your hole will be much better. Another term here, we have the shank length, since this tool should be embedded, mounted into a kind of a tool holder. So this part is used for that purpose, and this is the overall length of our tool. And in addition to these, sometimes you need to have such special chip breakers inside embedded into your teeth. Otherwise, you will have highly continuous chips, and as you know, we don't want to have continuous chips. It's always better to have discontinuous chips, and these chip breakers are intentionally embedded onto these teeth to have discontinuous type of chips during our broaching operation. And in addition to this straight, let's say, broaching, we also have turn broaching. As the name implies, we have such special broaches. With the help of the rotational motion, again, we can open different profiles on the cylindrical parts. This is the main difference. And then if we briefly discuss the broaching machines, they are divided into two main groups, push type and pull type, but the fundamentals are the same. Only the push types are quite shorter compared to the pull type, since if you are pulling, then you need to have more space to pull your cutting tool or the broach out of your hole or over your surfaces, but the rest is the same. And he said that these are quite productive, but the thing is that the manufacturing of the tools brochures are quite difficult and expensive. So if this is an highly suitable process for your case for the manufacturing of a specific part, then you should go with broaching. But if the number of products is lower, then instead of broaching, you may use different manufacturing or machining processes. Then we have another machining process called sewing. This is one of the fundamental or one of the oldest type of machining processes. How we do it, we use a kind of a saw, or sometimes we may call it as a blade, and then with again reciprocating motion of the saw, we can remove material and try to open some grooves or remove some portions of the work pieces. And in the saw, what we have series of small teeth. So this is a must for the saws. You see, we have many teeth after each other, and again we have rake angles, relief angles. We have tooth spacing, as in the case of broaching. And other thing, actually, I forgot to mention about gullet. It's an important issue. Let me go back to here. If you look at this cutting tool in broaching, the broach itself, we have such spaces here. These are called as chip column. They're actually kind of room to actually store these chips. Since even though you are generating discontinuous chips, it may be quite impossible or quite difficult to remove these chips out of your hole or over your surface. So that's why we need to have such special spaces to store these chips. And then later, once the brushing is over, then you can clean your tool and make them empty so that you can use the same brush in the next machining operation. We have the same type of color actually in the saw or in the blades you see here. They are quite similar, but in the sawing, our main aim is not the accuracy. Our main aim is actually to remove material, a large portion of material from the initial raw workpiece. But the thing is that resulting workpieces don't have a high dimensional accuracy. We obtain near-net shapes, and if you are going to use that part in your critical application, then you need to do some post-processing and do more maybe finishing or more machining operations so that the dimensional accuracy of your part will be much better. Another thing, in sewing, we are not removing too much material, and that's why the width of these actual openings are not too much. We call it as curve. The width of the curve is a little bit more than the width of your saw, but it's not too much. So as opposed to other machining operations, we are removing less material, but we can divide the part into some other smaller pieces or remove some portions from the work pieces. And if the materials are, if the work pieces you are going to solve have higher hardnesses, then what you need to do, you may use special saws which actually have special inserts at the tip of their cutting edges. Even you may replace these inserts or do some coating on the cutting edges, and with the help of these inserts or some coating, you may use the same saw for a longer time, and you can machine or you can do sewing on very harder work pieces. In addition to sewing, we have another version. It's called as friction sewing. This time things are a bit different. In friction sewing, we are not removing material with the help of the sharp edges. We are removing the material with the help of friction. So what happens if you have too much friction? We know that heat will be generated and the temperature will be increased, and we may liquefy our material. So once it's liquefied or softened, then with the help of this relative motion, our tool blade or disc actually can push this softened metal out of the cutting zone, and you have again kind of a curve in between the raw material, raw workpiece, and the removed portion. So this again can be called as a sewing operation, but this time we are not using sharper edges. And the thing about the friction sewing is that since the temperatures are high, we have heat affected zone around the curve. So you should be careful about this issue, since once the temperature of this zone is increased, the metallurgical properties might be affected, and you may have some problems and while you are using your part in the real applications. Another issue about the friction sewing is that it's most suitable for machining, removing material from ferrous metals. It's not preferred for non-ferrous, since if it's non-ferrous, then probably some material will be embedded into your blade, and at a point you may not be able to remove material. And we have another Machining process is a very simple machining process. It's called as filing, and we prefer to do it mostly manually. So we have kind of a simple tool, and what we do, we remove actually burrs from the corner, from the edges of the machined workpieces. And this is again one of the oldest machining processes. If it's a critical application for you, then you may look for some filing machines, but they're not that common. Instead of filing machines, we prefer to use some grinders or some other machining centers. But there are also a few types of filing machines. So depending on your main requirements, aim, you may go with a filing machine or continue using some grinders. In addition to these manual tools, you may also have a kind of a band files or rotor files. So they have a bit better productivity. So again, depending on the type of workpiece you are filing or the amount of workpieces, the number of workpieces you are going to file is important. You should consider all these and then later decide on the best type of machine and best type of filing approach.